Hi guys, and welcome back to Math Clips. Today we're going to look at Volume Lesson 9. Remember, the very first question is a question that you do not have on your paper. It is just simply an opportunity for you to watch and listen to how I work through the steps to get my solution. So let's get started. It says a wooden crate has dimensions 10 inches by 6 inches by 3 inches. You decide to double the length to fit longer items. So let's stop for just a second and make sure that we understand what a wooden crate is. And a wooden crate is like a wooden box. And a box is something that is three-dimensional, something that we could store items in. Let's make sure we're paying close attention. We have several steps that we're supposed to take here. The first one is to make a prediction. Will the volume double? Well, I see that only the length is doubling and not anything about the width and height will change. So I'm going to say no, that it won't double because only one dimension is changing here. The next step is to calculate the original volume and the new volume. So I'm going to go ahead and make a place to record my answers. There's going to be my original volume, and this is going to be where I put my new volume. And then the last step is to explain how did doubling the length affect the total volume. So I'm going to go ahead and set this up so I'll have a place to clearly work for my original volume and a place to work for my new volume. And I remember to find volume, it's length times width times height. They've already given me the dimensions, so all I have to do is plug them in here. 10 times 6 times 3. Okay, I think I'll go this direction. 10 times something will be an easy thing to work with. So I'm going to start with 6 times 3, and that gives me 18. Cross off what I've used so I don't use it again. Then I'm going to say 10 times 18, which gives me 180. So I'll record my original volume at 180 inches cubed. Now for the new volume, I have to keep in mind that only the length is doubling. So I remember length times width times height. Because the width and the height are not changing, I'll go ahead and plug those amounts in. 6 times 3. Now to pay close attention to my length is 10, and doubling is the same as saying times 2, so it would be 10 times 2, or you could just say 10 plus 10. Either way you look at it, 10 times 2 gives me 20, and 10 plus 10 also 20. So I'll write down my new doubled length of 20. Again, I'll go ahead and start with the 6 times 3, leaving that nice, easy to work with 20 sitting here. And 6 times 3 is 18. Cross off what I've used. And now I have 20 times 18. And 2 times 18 is something I may not be as familiar with. So because it's just times 2, I'm just going to choose to use repeated addition here. I get 16, carry the 1, and 3. So I got to remember my 0 sitting here, and that would be the same as saying 36 times 10, which would give me 360. So I will record my new volume, 360 inches cubed. So now I've made a prediction. I've solved for the original, solved for the new. Now I need to explain how did doubling the length actually affect the total volume. Well, my original was 180 inches cubed. My new volume is 360 inches cubed. I know that down here I saw when I was working out my new volume, when I doubled 18, it gave me 36. So if I were to double 180, it would give me 360. So I was wrong. It does change and double the volume. So just changing the length and doubling the length was enough to actually double the original volume to my new volume. All right. If you need to rewatch any parts of this, feel free to. Go ahead and pause when you are ready to get yourself settled with your paper, your pencil. Make sure your name is on your paper and be ready. We'll solve the next one together. Unpause to continue watching when you are set and focused. And let's get started on this question. This is the one that you should have there on your paper. A gift box has dimensions 12 inches by 4 inches by 5 inches. You decide to double the width to hold more gifts. Prediction: will the volume double? Well, mathematicians, what is your prediction? Will the volume double? After we worked through the first one together and I learned that just simply doubling the length was enough to double the volume, I'm going to predict that yes, that doubling the width will also cause the volume to double. The next step, calculate. Calculate the original volume and the new volume. And then my last step will be to explain how did doubling the width affect the total volume. So I'm going to go ahead and set it up, my original and my new. Make clear areas for me to work for my original, my new. Let's get started. Length times width times height. I'm going to use the dimensions that they've given me here because nothing is changing for the original. 12 times 4 times 5. I'm going to go ahead and start with this because I know that 4 times 5 is going to be a nice, easy number to work with, the product of 20 with that 0 on the end. I'm going to cross off what I've already used and bring down everything else. I'm left with 12 times 2, which is 24. With that 1 0, it's like saying 24 times 10, which gives me 240. So I'll record my original volume, 240 inches cubed. Now for the new volume, I'm going to start with my equation, length times width times height. Because my width is doubling, nothing's happening to my length and my height, so I'll start with those amounts, the 12 and the 5. So 12 times something, and then times 5. This is going to be my width, and it's going to double. And remember, doubling is the same as saying times 2, or I could just say double 4 by saying 4 plus 4, which gives me 8. I'm looking over my factors, and again, I think I'll start with 8 times 5 here at the end because I see that that's going to give me a nice, easy number to work with that 0 on the end, because 8 times 5 gives me a product of 40. Cross off what we've used and bring down the rest. 12 times 4 is 48, and then this leftover 0 is the same as saying 48 times 10 because 10 has the 1 0, and 48 times 10 is 480. So I'll fill in my new volume, 480 inches cubed. Now it's time to explain. And I can see here that I have a 24 and a 48. And if I had 24 plus 24, that would give me 8 and 4. Well, 48 is doubling 24. So in this case, it's 240 and 480. So 480 does indeed equal to the doubled amount of 240 inches cubed. So our prediction this time was correct. Okay, guys, go ahead and pause, get ready. Think about the next question because it's one that you will solve by yourself. If you need to rewatch this video to help you work through the steps of the third one there on your paper, then you're welcome to do so. When you feel like you've got it solved correctly, unpause and we'll be ready to flip over to the back side of your paper. I will see you shortly. Welcome back. I hope you didn't have much trouble. I'm sure you did great. Let's look through this one together. A shipping box is 12 feet long, 5 feet wide, and 4 feet high. You build a second box with a height cut in half. Ooh, so on the last ones we were doubling. This one we're cutting in half. I'm going ahead and thinking of, well, doubling is times 2. Half is the same as saying divide by 2. So we're going to need to predict, will the volume be cut in half? Well, I did learn that if I doubled one dimension, it actually doubled the whole volume. So I'm going to predict that if I cut one dimension in half, that it will, yes, cut the entire volume in half. Then I will calculate and find both volumes. That means, again, the original and the new. Then I will explain what changed and why. So let's get started. Again, I'll set it up, the original and the new. And for my original, I still need length times width times height. My dimensions are 12 times 5 times 4. I could either say 12 times 5, that would give me 60, or I could say 5 times 4, that would give me 20, both of which are very easy. But in this case, I think I'm going to stick with the 12 times 5 because 12 times 5 I already know easily is 60, and that might be easier than trying to work the other way. I'm going to cross off what I've already used and then say times 4. And I'm left with 6 times 4, which is 24. This 0 here is the same as saying 24 times 10, which equals to 240. So my original volume was 240 feet cubed. Now to get started on my new volume, I see that it's the height that I'm going to change. So length times width times height. I'm going to leave my height alone for a second and just work with my length and my width. So I have 12 times 5. That won't change. But my height will. And I just talked about how half means the same as divide by 2. So I'll take my original height and then say divide by 2, which gives me 2. So my new height will be 2. I see the direction I want to go here is to say 5 times 2 because that's going to give me an easy 10. Cross off what we've used, bring down the rest. And I'm left with 12 times 10, which is 120. So when I fill in my new volume here, I have 120 feet cubed. And was my prediction correct? Is 120 half of 240? Well, if I look at 24 and 12, I know that 24 divided by 2 gives me 12. So, yes, 240 is twice as much as 120, which means that our new volume, 120, is half of the original volume, 240. Okay, if you need to rewatch this part of the video, feel free to. Otherwise, get your pencils ready and let's start on that question you have there on the back side of your paper. And that question is, a storage bin is 10 feet long by 6 feet wide and 2 feet high. You build a second bin with a length cut in half. Let's make our prediction. Will the volume be cut in half? All right, what do you predict? Well, based on what we've been seeing, I'm going to again say yes. Could be wrong, but I'm predicting yes. Then we will calculate to find both volumes. Then we will lastly explain what changed and why. So I'll set this up for my new volume and then I got it backwards. Let me start over. Let me label this my original volume and then my new volume. Okay, set up my workspace for my original and new. So for my original, I'll start with my formula, length times width times height. And we remember a formula is like a recipe. It's like the ingredients that you need to solve for volume. So I have 10 times 6 times 2. I'll start this way because I see that 10 times 6 is going to give me a nice, easy to work with 60. Cross off what I've used and bring down the rest. And 6 times 2 is 12. This extra 0 is the same as saying 12 times 10, which is going to give me a product of 120. So I'll record my new volume, my original volume, 120 feet cubed. My new, I'll go ahead and start out with the formula length times width times height equals volume. And I remember that it's my length that I'm going to do something with. So I'm going to leave my length alone for just a minute and use my dimensions, my width and my height, because they're not changing. And I see that the length is going to be cut in half, and cutting something in half is the same as saying divide by 2. So I'm going to go over here to my original length, and that would be saying cut that in half. So 10 divided by 2 equals 5. So my new length is going to be 5. Go ahead and solve this. I'm looking through my factors. I'm going to go ahead and start with 5 times 6 because I see that's going to give me an easy to work with 30. Cross off what we've used and bring down the rest. 3 times 2 gives me 6. This 0 is the same as saying times 10, which gives me 60. So my new volume is 60 feet cubed. Will the volume be cut in half, and what changed and why? Well, I see here I started with that 120, but I'm going to focus on the 12. I ended up with 60. I'm going to look at the 6. Is 6 half of 12? Yes, it is. So 120 is twice as much, or the double of 60. So that means my new volume 60 is half of the original. So what changed? Well, my new volume is half. And why? Because all I had to do was cut the length in half. Changing only the length was enough to cut the volume in half. Okay, guys, you're welcome to rewatch this before you get started on that very last question. That one is not on the video because I feel certain you know exactly what to do to get this 100% right. I'll see you next time.